This is an Algebra 1 class, and today we're going to look at solving quadratic equations graphically. Before we go into solving it graphically, let's look at what it looks like to solve equations using factoring. If we want to find the zeros of the function f of x equals x squared plus 5x minus 24 by factoring, we're looking for the zeros, which means we want to make f of x equal to 0. So I rewrite this equation as 0 equals x squared plus 5x minus 24. And then I can factor this. Factors into two binomials. X squared is x multiplied by x. Factors of negative 24 that add to 5 are going to be 8 and negative 3. So we're going to have x plus 8 and x minus 3. Set each factor equal to 0. We have x plus 8 equals 0, or x minus 3 equals 0. Solving each one of those, we get x equals negative 8, or x equals 3. So when x is negative 8, or when x is 3, the function value is equal to 0. We can also find zeros by looking at a graph. Since f of x is equal to 0, we want to look where the y value, or the f of x value, is 0 on the graph. So let's take this same function, f of x equals x squared plus 5x minus 24, and let's graph this function and see where it crosses the x-axis, see where the values of y are equal to 0. In order to graph a function, the first thing we look for is the line of symmetry. So the line of symmetry, we use the rule x equals negative b divided by 2a. So in this function, a is 1 and b is 5. So we get our line of symmetry, x equals negative 5 over 2 times 1, or negative 2.5. To find our vertex, we now need to put this value for x into our function f. Remember, the vertex is always on the line of symmetry. So we're going to find the function value when x is negative 2.5. Substituting negative 2.5 into x. And then plus 24. Do a little math with that. We evaluate this on our calculator. We get negative 30.25. So our vertex is the ordered pair, negative 2.5, negative 30.25. Okay. Now, in order to graph that, we need to find points on one side of the line of symmetry. We're going to pick a few, maybe another point here. I've got room for 2, but I think I'm going to find a couple of more points here. So something that's on one side of this line of symmetry. We could go smaller than negative 2.5, or we could go larger. Let's choose some larger values. Let's see what happens when I put 0 in here. 0 is larger than this. So if I plug 0 in, I have 0 plus 0 minus 24. Our y values, notice, aren't anywhere close to 0, and that's where we want to find on the y graph where the y values are close to 0. So let's choose something bigger. Let's choose maybe 4. If I substitute 4 in, I'm going to have 16. Let's do that right here. F of 4 equals 4 squared, which is 16, plus 5 times 4, which is 20, minus 24. So f of 4 is going to be 36 minus 24, which is equal to 12. Okay. Let's see if we can get maybe one more point on here. Let's see what happens if we choose 1 for this graph. So let's find one more value, f of 1. Substituting 1 in, we have 1 squared plus 5 times 1 minus 24, and that's going to give us negative 18. So I'm going to put one more point on here. I'm going to do the ordered pair, 1, negative 18. Okay, so let's start by putting in our line of symmetry at x equals negative 2.5. I'm going by ones on the x-axis. Notice on the y-axis I've chosen a scale of 2, and since my values are mostly negative, I have most of my graph focused in the negative direction. So let's go to x equals negative 2.5 and just lightly dot in that line of symmetry. And our vertex is negative 2.5, negative 30.25, so it's right on the line of symmetry. Now at 0, we're at negative 24. And then I want to reflect that over the line of symmetry. Notice we're 2.5 squares, so I want to go 2.5 squares. Be right there. Okay. At 4, we're at 12, and it looks like that's almost off our graph, so let's choose 1 at negative 18. 10, 12, 14, 16, 18. And again, let's reflect that over our line of symmetry. And maybe one more point. So we're going to graph. It's going to go up. We don't know yet where it's going to cross that x-axis. It's going to be up a little ways yet. We're not sure. So let's see if we can estimate where 412 is. That's 2, 4, 6, 8, 10, 12. 1, 2, 3, 4. Here's our 412 point. We're going to head straight for that value. And we're going to have it on this side as well, which is going to be 1, 2, 3, 4, 5, 6.5 squares. So let's go 6.5 squares. There's my half. 1, 2, 3, 4, 5, 6, and up here. So we're going to end up at this point right here, and right here are 2 points on the x-axis. The coordinate of this point is 1, 2, 3, 0, and the coordinate here is 1, 2, 3, 4, 5, 6, 7, negative 8, 0. So zeros on the graph are at x equals negative 8 and at x equals 3. And those are the same values that I got for my solution by factoring. So visually, on a parabola, the zeros are on the x-axis. So point when y is equal to 0. And they're the same values we get when we set the function equal to 0 and factor and solve. So our zeros are at negative 8 and at 3, and these are also called the x-intercepts because they're on the x-axis. Let's do a couple more examples and see how that works. So to solve equations by graphing, we're going to get one side of the equation equal to 0, and then we're going to follow the same steps for finding the 0 of a function. So subtracting 3 from both sides gives us x squared minus 2x minus 3 equal to 0. And we're going to graph this function. We're going to graph f of x equals x squared minus 2x minus 3. So in order to graph that, we have to find the line of symmetry, which is x equals negative b over 2a. So our b is negative 2, so the negative of negative 2 becomes positive 2. And our a is 1, so we divide by 2 times 1, or 2 divided by 2, which is 1. So our line of symmetry is x equals 1. And now our vertex, we're going to use 1 into our equation. So f of 1 equals 1 squared minus 2 times 1 minus 3, which gives us negative 4. So our vertex is at the point 1, negative 4. Now let's find a couple of points on one side of the vertex. I can go larger than 1, or I can go smaller than 1. Let's choose 2 points smaller. Let's go 0 and negative 1. Substituting 0 into our function, we're going to have 0 minus 0 minus 3. And substituting negative 1, we're going to get 0. Let's go ahead and graph that. Our values are fairly symmetric, so let's go ahead and do that on a regular xy axis. X equals 1 is our line of symmetry. And our vertex is at 1, negative 4. We're at the point 0, negative 3, and we reflect it over the line of symmetry. And at negative 1, 0, reflecting over the line of symmetry, and we have our graph. The zeros, the places where y is 0, are at the ordered pairs negative 1, 0 and 3 zeros. So our zeros are at x equals negative 1, or the other 0 is at x equals 3. So we have 2 zeros. Let's do another one. Again, we want to get one side equal to 0 first, so let's add 2x to both sides. So we have negative x squared plus 2x minus 1 equals 0. And to graph it, we're going to look at the graph of f of x equals negative x squared plus 2x minus 1. Our line of symmetry, x equals negative b over 2a. The opposite of b is 2, so the opposite of b is negative 2 over 2 times our a, which is negative 1. So we have negative 2 divided by negative 2, which is 1. So our line of symmetry, again, is x equals 1. Our vertex, when we substitute 1 into our f of x equation here, we get f of 1 equals the negative of 1 squared plus 2 times 1 minus 1, and that value is 0. So our vertex is at 1, 0. Let's get a couple of more points on that graph. 2 points on one side of the line of symmetry, so we can go to the left. We would have x0 and maybe x negative 1. When we substitute 0 into our function, and I'll do that this time, f of 0, well, negative 0 squared is 0. 2 times 0 is 0, and then minus 1. So f of 0 is negative 1. And then f of negative 1, we're going to do the negative of negative 1 squared plus 2 times negative 1 minus 1. So f of negative 1 is equal to negative 1 minus 2 minus 1, which is negative 4. Okay, so let's graph this. Start with our line of symmetry, a dotted line at x equals 1. We're just going to use a scale of 1 in this case. And our vertex at 1, 0. Graphing our additional points, 0, negative 1, and reflecting it over the line of symmetry. Negative 1, negative 4. And again, reflecting it over the line of symmetry. We have this parabola that opens downward. And again, for finding the zeros are on the x-axis. They're the x-intercepts. There's one point that is at the 0, so we only have 1 0 at x equals 1. Okay, let's do a story problem application with this, and then we're going to be set. So one more problem. Here we go. An athlete throws a shot put with an initial vertical velocity of 40 feet per second. We want to write an equation that models the height h in feet of the shot put as a function of the time t in seconds. We learned in a previous lesson that the rule for an object or a projectile that's thrown or shot into the air is the height after t seconds, h of t, is equal to negative 16t squared plus our initial velocity times time plus the initial height. In this case, we have our initial vertical velocity, and it looks like we are throwing this. We're going to assume we don't have how high he is, so we're going to assume that he's throwing it from a height of the ground. Probably not, but we're going to use this as our height here because we're not given another height. So our h of t is equal to negative 16t squared plus 40t and our initial height of 0. Okay. We want to find a graph of this. So I've set up our graph. Time is always going to be positive, so I'm looking at mostly the positive quadrant. Our height is going to be above the ground, so I don't need anything in the negative quadrants here. On my horizontal scale, since time, it doesn't take very long at all for an object to go up and go back down again, I've chosen a scale of 0.25 seconds. And on the vertical, a height going by a scale of 2. So let's find our line of symmetry. We're going to have t equals negative b over 2a. So that's going to equal the opposite of b, which is negative 40. Over 2 times a, which is negative 16. So we have negative 40 divided by negative 32, and that value is 1.25. Now we want to find our height at that time. So h of 1.25. Substituting 1.25 in here, we have negative 16 times 1.25 squared plus 40 times 1.25, and when we put that in our calculators, we get a value of 25 feet high. So our vertex, 1.25, 25. At 1.25 seconds, the shot put is 25 feet in the air. Okay, now let's choose a couple of other points for time and h of time, our height at those times. We have, let's choose something to one side or the other. Let's choose 2 points smaller than that. Let's choose 1 and 0. Substituting 1 into our equation, we have h of 1 equals negative 16 times 1 squared plus 40 times 1. So we have negative 16 plus 40, which is 24. And when I use 0, h of 0 is negative 16 times 0 plus 40 times 0, which is just 0. So let's graph these points. We always start with our vertex and our line of symmetry. So our line of symmetry is at 1.25. 1.25 seconds on our graph. And it's a height of 25. So 2245. We have the point 124 reflected over the line of symmetry. And the point 0, 0, we want to reflect it over the line of symmetry. And graph down and down. So there are 2 zeros of this function. We have the point 0, 0, and we have the point 2.50. Okay, when we're looking at that, our question here is the time that the shot put is in the air. So the shot put is in the air from the time it starts till the time it lands. So from 0 seconds to 2.5 seconds, the shot put is in the air. So the shot put is in the air for 2.5 seconds. And that's our lesson for solving quadratic equations by graphing.